Hello everyone, welcome back to my channel, day 4 of Python learning series. So let's make a quick recap on what we have learned in the previous video. So we learned about the keywords, identifiers, variables, constants and literals, and we just had a look on the data types. We'll learn about the data types in detail in this video. So first data type is text data type. In Python, when we want to work with the text like names, messages or any kind of words, we use something called a string. A string is just a group of characters like letters, numbers, and symbols all put together. For example, the word hello is encoded in the double quotes is a string. In Python, we use the word str, which stands for string, to represent this type of data. To create a string, we put the text inside the quotes. Python allows us to use a single quotes like hello is encoded in the single quote, and double quotes, the world is encoded in the double quotes or even the triple quotes also. Here we can see hello world is encoded in triple quotes. All of these are correct ways to write the string. You can choose any one of them, but sometimes one type of code is more helpful depending on the situation. For example, if your text already includes a single quote inside it, like it's a nice day. So here between the T and S there is a single quote. So then you can use the double quotes outside. So Python does not get confused. And if your text goes across the multiple lines, you can use triple quotes to make it easier. Triple quotes are special because they let you write strings that cover more than one line, just like writing a paragraph. Let's look at some examples like hello is encoded in single quote is in a string using the single quotes, and world is encoded in the double quotes uses the double quotes, and hello world uses the triple quotes. All three are valid strings in the Python. They all mean the same. It's just text stored in a special way. To sum it up, a string is a piece of text that we put into a quote. It's a very common in programming because we often need to display the messages, take names as input, or work with a text in many other ways. Coming to the numeric data types, in Python, numeric data types are used to store the different kinds of numbers. The first type is int, which stands for integers. These are the whole numbers with no decimal points like 1, -10 or 100. You use them when you need to count or do basic math without fractions. The second type is float, which stands for floating point numbers. These are the numbers that do have decimals like 3.14 or -2.5. Floats are useful for things like money, measurements, or any situations where the exact value matters, including the part after the decimal point. The third type is called complex, which is used for advanced math. Like a complex numbers have two parts, a real part and an imaginary part. It's written with a j to show the imaginary part like 1 plus 2j or 3.14j. 3.14j. You might not use complex numbers often unless you are working on a specific or mathematical problems. In Python, you can easily check the type of any number using the type. It is in a type function, and use these types in calculation depending on what kind of numbers you need to work with. In Python, sequence data types are used to store collections of items, and the two most common ones are tuples and lists. Both are ordered, which means the items stay in the same sequence you put them in. The key difference is that the tuple is immutable, meaning once you created, you can't change it. You can't add, remove, or update its items. Tuples are written using the parentheses like this. You can see on the screen. There is an example 1, 2, 3 in a parenthesis, and that items are separated by the commas. Tuples are useful when you want to store the fixed data that should not change, like coordinators or constant values. On the other hand, a list is immutable, meaning you can change it after it's created. You can add new items, delete existing ones, or update values inside it. Lists are written using the square brackets like you can see on the screen. Example, it is a square brackets are enclosed, and 1, 2, 3 with the items also separated by the commas. This makes the list very flexible and commonly used in the Python for things like shopping list or user inputs, and more. So if you need a collection that stays the same, go with a tuple. If you need to change things around, a list is a better choice. Next, coming to the mapping data type. In Python, a mapping data type is manually represented by something called a dictionary, written as dict. A dictionary is used to store key value pairs. This means every piece of the data, the value, is connected to the unique value called the key. For example, if you want to store someone's information, you can do it like this. You can see on the screen, like name is encoded in the single code colon, and the John is also encoded in the single code. Similarly to the age and the 30. Here the value John and the age is another key that points to the value 30. You use curly braces here to create a dictionary, and keys and values are separated by the colon. Unlike the list or tuples, dictionaries are not based on the positions. You don't get items using the index numbers like 0 or 1. Instead, you get values using the keys like person and name to get the John. Dictionary are powerful because they make your data easy to organize and search. They are great for storing real world structures data like person's details, product information, or settings. And yes, while dictionaries used to be unordered in modern Python, like version 3.7 plus, they remember the order you added things in, which makes them even more useful. Next one is set data type. In Python, a set is a special type of the data structure that stores a collection of unique items. This means if you try to add the same item more than once, it will only keep one copy. Sets are the useful when you want to remove the duplicates or check for the common or different elements between two collections. For example, if you write open braces with 1 comma 2 comma 3 comma 2, Python will automatically stores it as 1 comma 2 comma 3. It removes the extra value 2 because set doesn't allow the duplicates. Sets are written using curly braces just like the dictionaries, but without key value pairs. Only the values goes in. Also, sets are unordered, which means the items do not have a fixed position and you cannot access them using an index like you do with the list. However, sets are great for operations like union, intersection, and difference. So, if you just need to store items without caring about the order and want to avoid the duplicates, a set is a perfect choice. Next one is the Boolean data types. Boolean data types are the special kind of the data in programming that can only have two values, true or false. Think of them like a simple switch, either on or off. These values help the computer make decisions. For example, if you ask a program, is the number greater than 10? It will check and return either true or false. If the value is greater, it returns true. If it is not, it returns false. Boolean values are often used in the logical operations and control flow, meaning they help to decide what happens next in the program. Here, the slide explains that in many programming languages, Boolean values are represented using the keyword bool. This means when you write code, you can use a bool to store true or false values. For example, in Python, you can write is raining equals to true, which means the program knows it is raining. If is raining is false, the program knows it is not raining. Boolean values are super useful because they help the programs make smart choices, like whether to show a message, turn on a light, or even decide if a user can log in. Coming to the next data type, none. In programming, none is a special value that means nothing or no value. Imagine you have an empty box. There is nothing inside it. In the same way, when a variable is set to none, it means it does not hold any actual data yet. So, this is useful when a program needs to check whether something exists or not. For example, if you ask a program, do we have a winner in the game? And there is no winner yet. The program might store none to show that no one has won. So here the slide explains that the none is often used when a variable has no assigned value or when a function does not return anything. In Python, for example, you can write result equals to none, which means the variable result does not have any data yet. Later, when the program finds an answer, it can change the result to the real value. This helps the program to keep track of missing or unknown information, making them more flexible and smart. Moving to the next topic, type conversion. Type conversion in Python means changing the type of a value from one form to the another. Imagine you have a number like 5 and if you want to treat it as in a text instead of a number, you can convert it into a string. So Python seems it is a 5 instead of number. This is the useful when you need to mix the different types of data like combining numbers with the words in a sentence. So here the slides explains that type conversion can happen in different ways. Some conversions happen automatically like turning an integer into a float when needed, while other requires manual conversion using the functions like string function, int function, float function. For example, if you have x equals to 10 and you write string of x, Python will change the 10 into the 10 has a form of a string. It is encoded in the double quotes, making it easier to use in the text-based operations. This helps the program work smoothly and when handles different types of the data. So here the type conversion in Python happens in two ways, implicit and explicit. So implicit type conversion means Python automatically changes one data type into the another when needed. For example, if you add an integer 5 to the float 2.5, Python automatically converts the integer into the float, making the result as 7.5. This helps to avoid errors and makes the calculation smoother without requiring extra steps for the programmer. On the other hand, explicit type conversion means the program manually changes a data type using the specific functions. For example, if you have a number stored as in a text 10, so you can convert it into an integer using the int function. This is useful when handling user input or mixing the different types of data. By using the functions like int function, float function and string function, programmers can control how data is processed and displayed in their programs. So you can see here these slides explain the type conversion in Python using the two examples. The first example shows the implicit conversion where the Python automatically changes an integer 5 and the float 2.5 into a float when added together. The result is 7.5 and when checked using the type of the result, Python confirms it as a float. So this happens because Python ensures the calculations are accurate by converting the smaller types like integers into the more flexible types like float. So the second example demonstrates like explicit conversion where a number stored as in a string 10 is manually converted into an integer using int of numString. After conversion, the program adds the 5 to the 10 and resulting in 15. So this is usually when working with a user input as the data often comes in a text form and needs to be converted into the numbers for calculations. So type conversion helps the Python handle different types of data smoothly. Coming to the conversion hierarchy, for data types in C, C++, Python, showing how different types can be converted from smaller to the larger types. So, at the bottom, short and character can be converted into the int, which can be then converted into the unsigned int. So, unsigned int means it is a positive value, it never takes the negative values. So the hierarchy continues upwards, allowing the conversions to the long int. So unlong, it's similarly unsigned long. So int, float, double and finally long double at the top. This means the smaller types can be safely converted into the larger types without losing the information. So however the diagram also includes a crossed out arrow labeled does not happen this way. So, indicating that conversions do not work in reverse. For example, a long double cannot be automatically converted into a character without losing the precision or causing errors. Understanding this hierarchy helps the programmers ensure that their data conversions are correct and avoid the unexpected behavior in their programs. So next, the slide explains built-in type conversion functions in Python, which help change one data type into the another. These functions allow the programmers to convert the values easily. For example, int function changes a value into an integer, while float converts into a floating point number. Similarly, string function turns the data into a string, making it useful for displaying numbers as text. Another functions help convert the data into a different collections. So list creates a list, tuple function makes a tuple, and set function forms a set. So which removes the duplicate values. And dict function is used to create a dictionary which stores the key value pairs. Lastly, bool function converts the values into true or false, helping with logical operators. These functions make the Python flexible and allow the smooth handling of the different types of data. This slide introduces the ASCII values. So, which are the unique numbers assigning to the characters like letters, digits, and symbols. ASCII helps the computers understand and store the text using the numbers. For example, the letter A has an ASCII value of 65, while B has a 66, and so on. This system makes it easy for computer to process the text efficiently. So in Python, two functions help work with the ASCII values. The order function converts the character into its ASCII number. So order of A returns 65 and the character function does the reverse. So it converts the ASCII number back into a character. So character of 65 returns A. So these functions are useful for encoding, decoding, and working with the text-based data in programming. Here, this slide introduces the operators, which are special symbols or keywords used in programming to perform operations on variables and values. Think of the operators as tools that help you manipulate data. For example, the addition operator adds the two numbers while the multiplication operator multiplies them. So, operators allow the programmers to perform calculation, compare the values, and even modify the data efficiently. So, there are different types of operators in programming, such as arithmetic operators, comparison operators, and logical operators. Each type serves a unique purpose, making it easier to write complex programs by using the operators. Programmers can create the conditions, perform calculations, and control how the data is processed in their code. Coming to the arithmetic operators, which are used to perform the mathematical calculations in programming. These operators helps with the basic math operations like addition, subtraction, multiplication, and division. For example, 2 plus 3 results in 5 and 4 into 2 gives 8. These operators are essential for handling the numbers in programs. Additionally, the slide introduces the advanced operators like modulus, which finds the remainder of the division, and the exponentiation, which calculates the powers. And another useful operator is float division, which gives the whole number result of a division. These operators make the mathematical operations more powerful and flexible in programming. I have given the examples for each operator. So once you go through with all the operators and type the code in the VS Code. Next, let's take an example for all the operators. So the slide contains a Python code demonstrating the different arithmetic operators using two variables like a and b. The code initializes the a equals to 10 and b equals to 3. Then it performs a variable calculations. So there we initialized and we declared that a equals to 10 and b equals to 3. Then so we perform the calculations like it prints the result of the addition, subtraction, multiplication, division, modulus, exponential. and float division. So each operator helps manipulate the numbers in different ways. So you can see there, just once you have declared a and b, then directly you can print using the operator a plus b, it performs the additions. So in each case of the print statement, we have just used the operator and it prints the result. So you once practice in the VS Code, once you just type the code which I have shown in the screen and just comment the output in the comment section. Assignment operators, which are used to update the value of a variable in programming. So the basic assignment operator simply assigns a value like a equals to 5, means a is now holds a value 5. However, there are compound assignment operators that perform the operations while updating the variable. For example, a plus equals to 3, that means it adds 3 to a and stores the result, which is the same as writing the a equals to a plus 3. So other operators also works similarly. A minus equals to 2 subtracts 2, that means a equals to a minus 2. So it subtracts from the same variable and it stores in the same variable. Similarly, a into equals to 4 multiplies by 4, that means a equals to a into 4. And similarly, division, modulo division, exponential, float division. So this all happens in the same way. These operators make the calculations more efficient and help the simplify code. So you can see that the image contains two blocks of the Python code demonstrating the different assignment operators and how they modify the value of a variable a. You once practice this code in the VS Code, so you can get some experience for these operators. So here the left block, you can see that the basic assignment operators, a equals to 10 initializes the a with the 10 and a plus equals to 5 adds the 5 to the a, making it 15. So a minus equals to 2 means subtracting 2, that updating the a to 13. And a star equals to 3, that means multiplying a by 3. So it results to the 39. Right side you can see the advanced assignment operators, like a divides equals to 4 means dividing the a by 4, making it 9.75. Below you can see a modulo division equals to 3. It finds the remainder when the divided by 3, resulting in 0.75. Next one, a equals to 2, then a exponent equals to 3. It rises the a to the power of 3, making it 8. So a equals to 10, then a float division equals to 3, means it performs a float division resulting in 3. So these operators help to simplify the calculations by combining the operations with assignment, making the code more efficient. Comparison operators. So you can see that the table of comparison operators which are used in programming to compare the values and return true or false based on the condition. So here you understand the comparison operators. Equal to means it checks if the two values are same. Example, 5 equals to 5. It is true because 5 is equals to 5. So not equals to means it checks the two values are different. For example, 5 is not equals to 3. True because 5 is really not equals to 3. Next one is greater than. So we already know these operators very well, like greater than, less than, greater than or equal to, less than or equal to. So these operators helps in decision making in programs, allowing conditions to be checked before executing certain actions. So you can see the example on the screen for the comparison operators to compare the two variables a and b. So here the variables are initialized and they are declared that a equals to 10 and b equals to 5. We assigned the values to a and b. Comparison operators like a equals to b checks a is equals to b or not. So it is false because 10 is not equals to 5. So similarly we have seen before example, it is also very easy. We know that not equals to, greater than, less than, and greater than or equals to, and less than or equals to. If it is true, if the condition is true, it returns true. If the condition is false, it returns false. So this operators helps in decision making in programs, allowing the conditions to be checked before executing certain actions. So logical operators which help in making decisions based on multiple conditions. These operators return true or false depending on the logic applied. So there are the types of logical operators like and, or, not. So here and it returns true if the both conditions are true. Like if 5 is greater than 3. It is true? Yes, it's true. And 4 is less than 6. Is it true? Yes, true. So here the condition returns true since both conditions are correct. Next, or. Or returns true if at least one condition is true. So look at the example. 5 less than 3? No, it is false. 4 less than 6? Yes, true. So in both conditions, one condition is true. So it returns true because 4 less than 6 is true even though 5 less than 3 is false. Next one, not. Not, it reverses the result making the true into the false and vice versa. Example, not y greater than 3. It is false since 5 greater than 3 is a true. It not makes it false. These operators are useful in programming for decision making, helping to control how a program responds to the different conditions. So here you can see the one more example for the logical operators and, or, not. And the three variables we have initialized a equals to 10, b equals to 5, c equals to 3. So you can use the logical operators there like print a greater than b and b greater than c. So here it checks the both conditions a greater than b and b greater than c are true since 10 greater than 5 is true and 5 greater than 3 is true. So the result is true. Next, or. So or it checks at least one condition is true. So 10 is less than 5 is false. 5 greater than is 3 is true. So the result is true. And for using the not, logical not, it reverses the result of a greater than b. Since 10 is greater than 5 is true. So not true becomes false. This logical operators helps in decision making as well and allowing programmers to evaluate the multiple conditions efficiently. Next one is membership operator, which are used to check whether a value exists within a sequence like a string, list or tuple. These are the two main membership operators like in operator and not in operator. In operator returns true if the value is present in the sequence. For example, A in apple. True because A is found in apple. Not in operator returns true if the value is not present in the sequence. So for example 3 not in a tuple 1 comma 2 comma 4. It is true because 3 is missing from the list 1 comma 2 comma 4. These operators help in searching for elements within collections, making it easy to check whether a value exists or not in Python. So you can see the example on the screen. I am providing examples for every operator. You just practice the code in the VS Code or any other available software in your laptop or in your phone. If you want me to suggest any apps in the phone to practice, you can comment below. I can suggest you. If you have laptop, it's better to use the VS Code for practicing Python. So the example for the membership operator is with a string and a list. So you can see example over there like text equals to hello. It defines a string and you can print e in text. E in text. It checks if the e is in hello true since e exists. So print z not in text. So z is not in text. Checks if z is not in hello true since z is missing. So this operator helps in searching for elements within sequences, making it easy to check whether a value exists or not in Python. Identify operator, which is used to compare whether two variables refer to the same object in memory. Mainly there are two identify operators. One is operator and is not operator. Is operator returns true if the both variables point to the same object. Like let's take example like A is B. True, because if A and B are same object in memory. Is not operator returns true if the both variables do not point at the same object. So example A is not B. True if A and B are different objects. These operators are useful when checking whether two variables reference the same memory location rather than just having equal values. Bitwise operators which perform the operations on binary numbers at the bit level. These operators are useful for tasks like encryption, compression, and low level programming. So, types of bitwise operators are AND, OR, XOR, NOT, left shift, right shift. So, here and returns 1 if the both bits are 1. So in the previous case we have already discussed about the AND operator, like in the logical operators, and if the both conditions are true the AND returns true. So here also it is similar. So in the bitwise operators and it returns 1 if the both bits are 1. So let's take an example 5 and 3. You can see the AND symbol for the bitwise operator on the screen. And example 5 and 3, so it is 1 because the binary value of 5 is 101 and the binary value of 3 is 011, so it contains 1 bit, so it returns 1. Similarly, or it has a condition, it returns 1 if at least one bit is 1. So I think you got it. Here 5 or 3, it returns 7 because the binary value of 5 is 101 and the binary value of 011. So here we can write, listen carefully, the last bit of the 5 is 1 and in 3 binary value the last bit is 1. So in the both cases it is 1. So what is the condition? It returns 1 if it has at least 1. So here both are 1s, so it returns 1. In second, see in the tens place, so first it has 0 in the 5 for the binary value of 5 and for the binary value of 3 the tens place has 0 and here 1, so it has at least one bit, so it returns 1. So similarly it returns 111. XOR is indicated with the cap symbol, so it returns 1 if the bits are different. So listen carefully. So the example is 5 cap 3, the binary value of 5 is 101 and the binary value of 3 is 011. So here you can see it returns 1 if the bits are different. So see the ones place in the binary value of 5 and the binary value of 3. So in 5 value the ones place has 1 and here in the number 3 binary value the ones place has 1. So both bits are same, 1 and 1, so it returns 0 there. So similarly remaining 2 bits also it returns 110. So the value of 110 is 6. I think you got it now. Similarly, NOT, it inverts all the bits, flips 1 to 0 and vice versa. Left shift moves the bits to the left, multiplying the numbers. Example 5, left shift 10. Because the binary shift 101 returns 1010. So the value of 1010 is 10. Like this, right shift, it moves the bits to the right, dividing the numbers. Example 5 right shift equals to 2 because the binary shift 101 is shifted to the means it moved to the right, so 10 is remained, so the value of 10 is 2. So these operators help in efficient computation and are widely used in the system programming and the data processing. It might be some difficult, but if you do practice it will be very easy. Once you understand you can do any problem. So I have displayed some code over the screen. You just practice that code in the VS Code. The values are assigned as A equals to 5, B equals to 3 and the binary representation shown in the comments. So uh, just before I explained the manual process how we calculate those operations. But in the Python, if we do coding, you don't need to do all that manual process. The Python itself runs the program and does all the process that which I have explained you before. Python operator precedence chart, which organizes the operators based on their priority in expressions. Operators with high precedence are evaluated first, while those are with lower precedence are evaluated later. Like if we solve a math problem, we follow the bottommost rule, right? So first we solve the multiplication, then addition, then subtraction. Similarly in Python, there is an operator precedence. We need to know which operator need to be solved first. Like this, we have the precedency chart here. So you can see here the exponential has highest precedency. Next we have like unary operators like plus, minus and bitwise not, and next multiplication and division, and next addition and subtraction, and followed by bitwise operators, comparison, identity and boolean operators. Understanding operator precedency helps ensuring the expressions are evaluated correctly, avoiding unexpected result in Python programs. Next, comments. So, the comments in Python, which are special notes written inside the code that Python ignores when running the program. Comments are useful for explaining what the code does, making it easier for humans to understand. So, there are mainly three reasons why we use the comments. Like improving the readability, helps the programmers to understand the purpose of the code, and second one is debugging and maintenance. It helps it easier to update or fix the code later. And next one is collaboration, helps the teams work together by providing the explanations. The types in the comments used in programming languages are single line and multi-line. So single line start with the hash and continue until the end of the line. So example, you can see there, like you start with the hash and this is a single line comment. So multi-line comments like enclose the triple quotes and can span multiple lines. These comments help the programmers document their code and make it easier to read and maintain. So I'll post some questions based on these topics. Just try to solve those problems for better understanding. That's all for today. If you have any doubts, let me know in the comment section.